Okay, so I'm going to be explaining the limit laws now, and I'm not going to try to ramble on that much. I'm going to try to teach at a faster pace, so I don't have to render as much, because, I don't want to make my videos long, because who likes long videos where, like, the narrator is just completely rambling? Okay, I'm just going to start off. This is the limit of the difference is equal to the difference of the limits. That's the second limit law. So the third limit law is the limit of a constant times a function is equal to the constant times the limit of the function. Okay, so the limit of a constant times the function is equal to the constant times the limit of the function. All right, that's the third limit law. The fourth limit law, the limit of a product. Sorry about that. The limit of the product is equal to the product of the limits. The limit of the product is equal to the product of the limits. Okay, that's the fourth limit law. Now let's see. I'm not rambling on as much because can't have that happen. Y'all gotta understand math. Okay, so this is the fifth limit law. My tablet just keeps disconnecting, and this is the limit of the quotient. The limit of the quotient. I don't think that's necessary, but this is the limit of the quotient. Is equal to the quotient of the limits. You guys got the pattern. And this is if the limit of x approaching a of g of x is not equal to 0. The only reason why you don't want g of x equal to 0 is, like, you guys learned this in algebra. I learned this in trigonometry. Don't recall this in algebra 2, but honestly my algebra 2 teacher, I don't know. I don't recall her telling us this, but any number with 0 as a denominator is undefined. And any number with 0 as the numerator is 0. So yeah, hope you guys knew that. You guys did. I don't know why you guys are in calculus, but yeah, just kidding. It's fine. We forget things. We don't care about them. Just harsh truth. Okay, so where n is a positive integer. This is just the limit. I don't know how to explain it. It just says the limit of it, where n is the positive integer. Then get limit of x approaching a of f of x to the power of n, which should be a positive integer. Okay, so that's all, like, the limit law in word says. Okay, so the limit law number 7, the limit of so the limit of a constant is equal to the constant. Next, the limit of a linear function. So just review. This is a linear function. It's just linear function. Y equals x. It's derived from the formula. Please stop intercept formula. Okay, so that's a limit. The limit of a linear function is equal to the number x is approaching. This is the number. So the limit of a linear function is equal to the number where the limit is approaching, where x is approaching. And this what would I say, equation? Because equation is just something equal to the limit x is approaching a, so then it equals a. So number 9. Okay, I need to clear this up. Oh, great! Under 5 minutes. I'm so happy. I thought it was under not 5 minutes. keep it short and simple. Straight to the point. Everyone loves that. Okay, so the limit of x approaching a of x to the power of n, where n is a positive integer. It just says where n is the positive integer. 9, 10, limit of x. This is a rational. Radical? It's a radical. Please, number is approaching. So where n is a positive integer and if n is even, we assume that a is greater than 0. It's difficult. I think this is like the easiest part of calculus. Oh yeah, I think a derivative is defined from x minus fx over h. Okay, so number 11, limit of x approaching a of n f of x is equal to n radical limit a of f of x. So where n is a positive integer, n is a positive integer. I think integer is just any number on a number line. Right. And if n is even, we assume that if n is a positive integer, and if n is even, then we assume that the limit of x approaching a of f of x is greater than 0. Alright, I'm done. Please tell me it was 5 minutes. It was 7